Proxima Centauri is a planet orbiting the closest star to Earth, and it is ironic that Proxima Centauri looks so much like Earth and is so close to us. The scientific community has been surprised by Michio Kaku's discovery of planets even more favorable for life than Earth in our galaxy, known as habitable exoplanets. Although Earth generally has a favorable environment for life, why not aim for something better? Imagine worlds with lots of water, fewer deserts, balanced temperatures, and more land. Paradise could exist somewhere. Scientists have identified some candidates for humanity's future. The holy grail of astronomy is to find a close terrestrial twin, a double planet in space, and now we have achieved it. Renowned physicist and co-founder of string theory Michio Kaku has high hopes for the future of humanity. He believes that humanity can become immortal and perhaps advance to become a two-planet race, conquering other universes. This is crucial in the event of supervolcanoes, glaciations, or meteorite impacts that could cause catastrophic damage to Earth. The first stage is to leave Earth and populate other planets because the Sun will consume Earth in 5 billion years. In the distant future, we could find a planet in the galaxy similar to Earth and settle there. However, we may be looking for extremely habitable planets rather than simply Earth-like ones. The celestial world could have even more potential to harbor life. In 2004, René Heller and John Armstrong presented the idea that determining the actual habitability of a planet requires more than just knowing whether it lies within the habitable zone of its star. The search for extremely habitable planets is unclear, as Earth, the only planet we know to be inhabited, may not have the ideal physical and chemical conditions. Liquid water is necessary for life, so we can search for Earth-like exoplanets. However, other scientists argue that compared to Earth, other types of planets might offer favorable or even better circumstances. The search for extremely habitable worlds suggests that planets need not be Earth-like to harbor life. They may present even better opportunities for the formation and evolution of a wide variety of species. A superior world, such as a planet or moon, could harbor a greater diversity of flora and fauna than Earth. Despite the belief that Earth is the limit of planetary habitability, there could be planets more favorable for life. Not all rocky planets located in the habitable zone can be considered habitable by default. For example, in the inner ocean of Jupiter's moon Europa, tidal heating can make terrestrial or icy worlds outside the habitable zone habitable. Our obsession with finding Earth-like worlds could hinder our research in exobiology. A change of perspective is needed to identify extremely habitable worlds. Biological factors should be prioritized over geocentric and anthropocentric ones. Astrobiologists believe we may overlook alternatives, such as worlds better than Earth, because of our fixation on finding a second Earth. The idea that Earth is the most habitable planet in the universe is challenged by the existence of superhabitable worlds. In an effort to broaden our search, Heller and Armstrong suggested creating an exoplanet profile that includes a number of variables, such as star type, planetary mass, and planetary system. Today, life is being sought beyond yellow dwarf stars like the Sun, as well as in systems around red dwarfs, which are smaller, fainter, and cooler than our Sun but have lifetimes of between 20 billion and 70 billion years. Orange dwarfs could offer planets more time for the development of life and greater biological diversity. Complex life on Earth emerged after 3.5 billion years, so older planets have certain advantages, but they should not be too old as they would eventually run out of their natural geothermal heat reservoirs and protective geomagnetic fields. The researchers proposed that the age of the planets should be between 5 billion to 8 billion years. While Earth is approximately 4.5 billion years old, the mass and size of a planet have a direct impact on its ability to support life. A planet 10% larger than Earth would have a larger habitable surface and could maintain a larger, more stable atmosphere, creating ideal conditions for life. If a planet has a mass 50% greater than Earth, the longer radioactive decay period will provide a constant heat source, prolonging the time its core and vital magnetic field remain active, favoring the emergence and evolution of life. Additionally, a planet with more mass would experience greater gravitational forces, which would prolong the rotation of its atmosphere. The atmosphere is more conducive to life the longer it persists. If we visited such a planet, the increased gravity would make walking more difficult, but this would be a minor problem compared to the difficulty of reaching such a world. Extreme habitable worlds could exist if they show a modest increase in temperature compared to Earth. On our planet, the largest tropical areas support greater biodiversity. The warm, humid conditions of tropical forests are home to a surprising variety of species. However, due to the development of deserts caused by rising temperatures, warmer planets may require more precipitation. Water is essential for all life on Earth and is a key component in the search for planets that can support life. Additionally, planets with landmasses similar to Earth but divided into smaller continents would provide a more favorable environment for life. In our own world, a greater variety of life is found in the shallower regions of our oceans than in the deepest ones. As a result, planets with smaller masses of water could be better suited for supporting a wide range of life forms. Despite current challenges, researchers continue to search for indicators of habitability, although some of these situations are still beyond our current observation capabilities. Alpha Centauri b has shown itself to be a very interesting target in the search for extremely habitable planets, but so far, none of the planets in Alpha Centauri have been proven to be inhabited or extremely habitable. Proxima Centauri is a red dwarf star that is just 4.2 light-years from Earth and could have habitable or even super-habitable planets. Proxima Centauri is one such planet that is located in the habitable zone of this dwarf star. Although Proxima Centauri has the potential to support life, it faces great difficulties due to tidal locking events and stellar activity. UV radiation from Proxima Centauri could disrupt the ozone layer, resulting in dangerously high levels of UV radiation. Due to the tidal locking effect, Proxima Centauri b does not experience regular day-night cycles, but if it has oceans, tidal forces could cause droughts and flood cycles in coastal environments, encouraging the formation of biological rhythms similar to day and night cycles. Currently, there are more than 5,000 verified exoplanets in our galaxy alone, and many more potential discoveries are awaiting observation. Researchers at Washington State University have suggested that exoplanets could exist with environments even more favorable for life than our own.